Welcome all. Is my audio clear? Is everything clear? Is my audio clear? Yes. Hope everything is fine. Chalo, let's start. Okay. People are joining. Chalo. So, sab clear hai na, sirs? Everything is fine na? Right. I'm good. Yeah. Come on, please join. हिमेश शर्मा आ गए देखो, साई राम, सचिन बाबू, ग्रेट. और कौन, बड़े लोग सब आ गए. चलो, okay. Just wait for 1 minute, so we'll start. One second, please. One second, please. Yes, Omijit.
Sir, you were live on engineering ka funda, mechanical ka funda, but you are not live on basics like sir. Like, can you just check once, sir, or like check like if any issue is coming?
No. Everything is fine.
So I don't know, sir, why it's not like showing live on that one. Sir, like that you have pressed that second start as well, no?
Yeah. I've done both. So now I'll continue. So let's, okay? I'll continue. Okay. Chalo. Yeah. So everything is fine now? So my dear students, a very good evening to all of you. So today I'll start your psychrometry. You know, refrigeration and air conditioning is divided into two parts. One is refrigeration, other is air conditioning. So I'll try my level best to cover this psychrometry portion which comes under AC, that is air conditioning, in a very detailed conceptual manner along with all varieties of questions. Okay, right. Now, so it's a humble request to all of you. So if you are attend regularly, please. So I'll try my level best to show you the complete details of this psychrometry. Now, so are you ready, my dear students? So are you ready? Chalo, let me see your comments. Ready na? Okay, great. Chalo. So let's proceed. Now, the program is something like this. First, I'll discuss what exactly psychrometry is, what are psychrometric parameters or psychrometric terms, and I will derive wherever equations are possible, I'll derive all those equations. Then we will take up some wide varieties of good numericals so that it will benefit you both from GATE and engineering services point of view. And apart from that, I'll be taking up some of the interview questions also. Dekho, see, your interest, it matters a lot. So generally after 3 years I am coming live. It means कि live का मतलब क्या है? I covered one topic that is theories of failure 3 years ago, and now I am coming after 3 years for a particular topic that is psychrometry. So recently we launched a new channel that is Mechanical Ka Funda, and your response to that is so amazing. So that has motivated us to move in this direction. So let's proceed, my dear students. Now, what exactly is psychrometry? Without wasting time, let us start. So at the end, I'll take up your questions. Now, I will not check your comments. If I start checking your comments, the flow will be disturbed. Okay? If I start checking, the flow will be disturbed and I'll be continuously focusing on your comments. It is not a good sign. So let me focus on content first. In the last 5 to 10 minutes, I'll take up your questions. Will that be fine? Ek baar bolo. Will that be fine, sirs? Will that be fine? Will that be fine? Okay, ek baar bolo. Thoko tali. Bolo re. Right. Okay na? Chalo. Now, my dear students, you know our syllabus is divided into two. One is refrigeration, one is air conditioning. In refrigeration, we just control temperature. It is the science of maintaining lower temperature compared to surroundings. So that you will be studying in refrigeration. Now, what is air conditioning? Okay. My dear students, let us say the temperature is about 45 degrees centigrade. Are you comfortable at 45 degrees centigrade? Absolutely no. Let us assume that the temperature is about 5 degrees centigrade. Are you comfortable at 5 degrees centigrade? No. It means there is a need for us to regulate the temperature. So the first parameter that I need to regulate for my comfort is temperature. Very good. The first parameter is temperature, because at high temperatures we are not comfortable, at low temperatures we are not comfortable. So therefore there is a need for us to regulate or control the temperature. Great. First parameter we have seen. You might have heard the term humidity. First, let us discuss in a loose manner, in a crude language, in a layman's language. Just humidity means amount of water vapor present in air. Now the question that comes to our mind is, how do you know that there is a water vapor in air? Good. You take a cool bottle from refrigerator and expose it to atmosphere. You know, the air, when it comes in contact with the colder surface, whatever water vapor is present, if the temperature of the surface is very, very low, the water vapor which is present in air will undergo condensation and you will be seeing droplets on the surface. It clearly shows that there is water vapor in air. And that water vapor, in a loose term, I call it as humidity. So now I have not yet defined what is specific humidity, what is absolute humidity, what is relative humidity. Forget about those technical terms. First, let us see in a loose language. Humidity right now is water vapor which is present in air. Okay. Dear students, what happens if the humidity is more? If the humidity in air is more, let's see what happens. Dear students, at every particular temperature, air has got capacity to absorb moisture. So after that, it cannot absorb. That maximum moisture which it can absorb at a particular temperature, you call it as saturation state. Let me tell you very clearly, sirs. My main aim is to give content and concepts without wasting your time. So I may not be checking your comments quite often. So please, my dear students, involve in subject and learn to the maximum as if you are in classroom, and treat this as the temple of learning and sit in an alert manner and learn. I will try my level best. I will give my best. Okay. Now, if the humidity is more, what will happen? If the humidity is large, what will happen? You know, my dear students, let us say I have done some activities. I am running. When I am running, I am sweating. So if humidity in air is very large, will it absorb? Already it is large in air. So it cannot absorb because the gradient is the difference is very small. So therefore it cannot absorb. So whatever the sweat is that is developed on the skin, it will stay and you will feel sticky sensation. So higher humidity, you are not comfortable. Now let us see the other way. Let the humidity be low. If the humidity is very, very low, generally you find that in winter conditions. I'll be explaining to you why in winter the humidity in air is low when I take up your actual psychrometric processes. So in winter, if the humidity is low, in air the moisture content is low, so it will start absorbing because it needs now. Because as the moisture content is low, it will keep on absorbing. So you know, under the skin there is moisture. So as moisture in air is less, it will absorb, and thereby your skin will become dry. That's why you see in winter white patches. That's why you will be going for artificial moisturizing like Pond's Cool Cream or so. So it clearly shows that when the humidity is large or the humidity is small, you are not comfortable. So the second parameter that you need to control is humidity. Humidity. We'll see how we are controlling. Now, my dear students, we have regulated the temperature. So whatever the temperature you want, I'm giving it to you. Let us say you want around 25 degrees centigrade. I'm providing you 25 degrees centigrade. Let us say you want a particular humidity. I'm giving you that also. Dear students, the most important parameter is air velocity. So if air is blown at a higher velocity, you are not comfortable. And if air is blowing at a lower velocities, then also you are not comfortable. So the third parameter is the air should flow at optimum velocity. So the third parameter that you need to regulate is air velocity. It is air velocity. Don't worry, sirs. I'll be giving you practical values like what are the values for optimum comfort. So I'll be giving you. First, let us see the broader idea of the subject. Now, fourth one. Dear students, the most important part is purity of air. Assume that I am giving you air at a required temperature and at a whatever the humidity you want I am providing, and whatever the air velocity you want I am providing. But if I am not providing you pure air, something like, what do you mean by pure air? If air is let us say there is more carbon dioxide in air, will you be comfortable? No. So if there is more carbon dioxide, then also you are not comfortable. So the fourth parameter is purity of air. So now let us understand carefully. What exactly is air conditioning? It is the simultaneous. What do I mean by simultaneous? At a time. In refrigeration, we were controlling only one parameter, that is temperature. But in air conditioning, you have to control these many parameters. So how do I define air conditioning? It is the simultaneous control of temperature, humidity, air velocity, and purity of air. At a time, I have to control all this. Dear students, it is not that easy. But we'll see that how we are controlling. So don't worry. You are conditioning what? I am conditioning air. It is air conditioning. I am conditioning air. So when you are conditioning air, is it not your responsibility to know properties of air? Is it not your responsibility to know completely about air? Yes, it is our responsibility to know completely about air. So that's why before we go for air conditioning, we will be staying in one department which gives us the study of properties of air. First, we have to study clearly. When you are conditioning air, you should know completely about air. When you are joining some job, you will be knowing completely about that job. So similarly, when I am conditioning air, I should know completely about air. So the branch of science which deals with the study of properties of air, we call it as psychrometry. So directly we do not go for air conditioning. So we will be in one branch, we will be in one department, that is psychrometry department, which tells us about the properties of moist air. Now you may be wondering, sir, what do we mean by moist air? I will be telling you everything in a crystal clear manner. So what is psychrometry? It is the branch of science which deals with the study of properties of moist air. So please tell me, up to this, is it clear? Is it clear, my dear students? My dear students, is it clear? Bolo re. Bolo, sirs. Up to this, is it clear? Everyone. So is the pace, is everything clear? Is the pace everything clear? So shall I proceed with this? Great, wonderful sir, thank you, thank you, thank you. Now our topic for today is psychrometry. Psychrometry. Let us see what is psychrometry. It is the study of properties of moist air. Now we have to understand what is the meaning of moist air, or simply I call it as air. Dear students, I may be using the word air or I may be using the word moist air, both are same. तो ये क्या है sir? Dear students, this air or moist air, from now onwards, whenever I use the word air, it means moist air. Let us see what is moist air. Let us see what is moist air. This air or moist air, we divide it into two parts. Let's see the reason for the division of this air into two parts. One is known as dry air and the other is known as water vapor. So I'll designate this water vapor with WV, water vapor, or V, and dry air with DA. Dear students, this dry air has different gases like nitrogen, oxygen, carbon dioxide, and some inert gases. Generally, if you see on mass basis, nitrogen is about 77 and oxygen is about 23. Now you may be wondering, sir, both put together is 100. What about this? Array, dear students, it is actually 76 point something and this is 22 point something. So I am rounding it off. Actually, there are very little percentage of this. It is on mass basis. What does mass basis mean? If you take 100 kg of air, in 100 kg of air, approximately 77 kg will be nitrogen, 23 will be oxygen. It means 76 point something is nitrogen, 22 point something is oxygen, remaining is other inert gases. You do one thing now, you take air at Hyderabad, at like Hyderabad conditions. Now you take air at some other place like Mumbai. Dear students, the place which is near coastal area, you may be seeing the humidity or moisture content more. Means water vapor may be varying from place to place. So that's why, so at some places water vapor may be more, at some places water vapor in air may be less. So water vapor is known as variable component. I repeat, so our air is a two component system. Now you may be wondering, sir, why is it two component? Why not nitrogen 1, oxygen 1, carbon dioxide 1, inert gases plus water vapor? Why not 1, 2, 3, 4, 5? Dear students, it is a fixed part. So wherever you go and take, if you remove water vapor and if you take dry part of air, this dry part of air means without moisture. This dry part of air means without moisture. This dry part of air means without moisture. If there is no moisture, if you take only dry air, in that dry air, you have nitrogen, you have oxygen, you have carbon dioxide and other inert gases. That is a fixed part. You'll be seeing whether you go to Bombay or Hyderabad or Delhi, the dry part has same composition almost. That's why that completely is taken as a single pure substance. But water vapor, it varies from place to place. So इसीलिए it is a two component system. One is dry air part, other is water vapor part. So dry air is a fixed part and water vapor is a variable part. Now the question comes, sir, why water vapor is a variable part? Because it varies from place to place. At some places water vapor may be more, at some places water vapor may be less. That's why the moist air or air is a two component system with one fixed part, that is dry air, and other variable part. Now let's proceed, sirs. You may be wondering, see, I am sweating. See, I am sweating. Means even a small humidity in air, it can have some huge effect. We will be seeing that. Even 1 gram, 2 gram per kg, it has an adverse effect. We'll be seeing that in a beautiful manner. Let us learn conceptually. And you cannot learn subject in a day or two. There has to be a struggle. Let's see whether that struggle is worth or not. Chalo, koi problem nahi sirs. Now understand carefully. So now this dry air and water vapor. Great sirs. So what is psychrometry? It is the study of properties of moist air. Why do we have to study sirs? Because we are conditioning air. Because we are conditioning air. So if you are conditioning air, you should know properties of air. Wonderful. So now we'll start with this. So can I say air or moist air is a two component system? Yes, it is a two component system. What are those two components? Water vapor and dry air. Dry air is a fixed part and water vapor is a variable part. I'll show you one more point here. Dear students, let us take a cooling coil. This is a cooling coil and its temperature is very low. Now this is surface temperature of the coil is very, very low. Now air is entering. Whenever I say air, what does it mean? It is a moist air. It has both dry part and water vapor. Okay. So this has dry air and it has water vapor. Let us assume that the dry air mass is 1000 gram. Just imagine whatever the air I am taking, in that air 1000 gram is dry air and say 25 gram is water vapor. Okay, 20 gram is water vapor. Now this air is flowing. Which air is flowing? Moist air. And what is the surface temperature of the coil? Let us say it is very, very low. What will happen, sir? The water vapor which is present in air, after coming in contact with the colder surface, will undergo condensation. Once it undergoes condensation, it loses it loses some water vapor. By the time it comes out, you tell me what will happen. Which part is getting reduced? It is the water vapor. My dry air, it's not condensable. It's not condensing. So water vapor is undergoing condensation. So whatever the dry air is entering, the same dry air is leaving. Let the mass of dry air, already it is 1000 gram, it will come out 1000. But you know, let us assume that 5 gram of water vapor is removed from this coil, from this air. 5 gram is removed. So entering was 20 and 5 gram is removed. Now it is 15 gram. Now can you tell me which one is variable part, which one is fixed part? Therefore, my dear students, dry air, whether it is oxygen, nitrogen, carbon dioxide, it is a fixed part. Whatever the dry air is entering, it is leaving. But only variable is what? Water vapor. And my dear students, we will be seeing that in air conditioning, all our calculations are based on fixed part. हम आगे बताएंगे sirs. I'll show you. All our calculations are based on fixed part. Which one is fixed part? Dry air. I'll show you everything clearly, don't worry. Hope you have understood what is a variable component, what is a fixed component. So my moist air is a two component system, that is dry air and water vapor. Wonderful, sirs. Now let us enter our psychrometry department. Now I have come to psychrometry department. I have taken my bag and I'll be here with my bag for a few days. Once I am confident with psychrometry department, then I'll go to air conditioning. But air conditioning is not there in GATE syllabus. It is there in engineering services syllabus. Now we will cover first psychrometry. Wonderful, my dear students. Wonderful students of India. Sirs, आप सिर्फ पढ़ाई करो, नो साइड टॉक्स, नो नॉइस, सिर्फ और सिर्फ पढ़ाई करो, आपका सब अच्छा होगा. सिर्फ पढ़ाई करो and nothing more, nothing less. Now I'll come to psychrometric terms. Psychrometric terms. Great. Let me take the first term. Sirs, क्या कर रहे हैं सर आप? My dear students, I am trying to understand all terms associated with air. Why are you studying this? Because I am conditioning air. When I am conditioning, अरे यार आप कुलकर्णी सर से क्लासेस पढ़ रहे हैं तो आप पहले इंक्वायरी करेंगे ना, कैसे पढ़ाते, क्या नहीं, तो ये नहीं बिना करे आप आएंगे नहीं ना. So same is the case. When I am conditioning air, I should know something about air. That is this something. So the first term is specific humidity or humidity ratio. Specific humidity or humidity ratio, and it is designated with omega. Now some books also call it as absolute humidity. थोड़ा फर्क है सर, वो भी देखेंगे हम, but generally we call it as specific humidity or humidity ratio, but some people also call it as absolute humidity. कोई फर्क है क्या? First we will see this, then we'll introduce one term, absolute humidity. Great. अब आराम से देखो सर. Let us take a sample of air. Whenever I use the word air, it means it is moist air. So let us assume that I have taken some sample of air. This air has two parts, water vapor and dry air. Let mv be the mass of vapor, water vapor, and ma be the mass of dry air. Please note down that this A is standing for mass of dry air, Ma. Mv is standing for mass of water vapor. Now, let us define what is omega or specific humidity. And after derivation, let us see the physical meaning of this omega. Let's see the physical meaning of omega. This specific humidity is defined as the ratio of mass of vapor. देखो सर एक term clearly, it is talking about humidity. Whenever it talks about humidity, it is the vapor mass. Whenever it says humidity, it is the vapor mass, sir. Whenever it talks about humidity, it is water vapor. देखो, this specific humidity is defined as the ratio of mass of vapor to the mass of dry air. यहां पे डाउट आएगा सर. यहां पे students get some doubts. Sir, what is the total mass of the mixture? The total mass of the mixture is mv plus ma. Why are you not defining specific humidity as mv, mass of vapor, to the total mass of the mixture? वो doubt when I was a student मुझे भी आया था सर वो doubt. So actually when you say some fraction, for example, let us say the total class strength is 100. Total class strength is 100. Boys are 70, girls are 30. Generally, what is the percentage of girls? I say 30 by 100. यहाँ पे भी mv by, it should be ma plus mv. But I'm not defining mv by ma plus mv, but I'm defining omega as mv by ma plus, not mv, just mv by ma. Just now I told you, in air conditioning, our calculations are based on fixed part. So dear students, ओमेगा mv is a variable part. यहां पे भी अगर वेरिएबल पार्ट लिखेंगे, so numerator is changing, denominator is changing, it becomes difficult for us to analyze. So therefore what I am doing is, please listen carefully, dear students, एक second. So what I am doing is, please understand carefully. So if here also it is mv is a variable part, numerator is changing, denominator is changing, so I cannot get a clear picture. So if I fix this and only this is variable part, if mv is increasing, omega is increasing. If mv is decreasing, omega is decreasing. So therefore, because this is a fixed part, I can easily tell you whether omega is increasing or decreasing. That's why we don't express in terms of total, but we express in terms of what? With dry part. What is this dry part, ma? It is a fixed part. Are you have not, have you followed, sirs? All of you, have you followed? बोले रहे, आप कुछ नहीं बोल रहे. Are you following? Are you following, sirs? Are you following? Yes, yes. Wonderful students of India. Wonderful students of India. So this is the fixed part. तो इसको हम कैसे एक्सप्रेस करेंगे, sirs? तो dear students, I don't write plus mv because numerator is varying, denominator is varying. For example, my dear students, let us say it is 3 by 3 plus, let us say this is 1000. 3 by 1000 plus 3. Now let us say it has increased to 4. 1000 plus 4. तो ये भी change हो रहा है, ये भी change हो रहा है. I don't get a concrete picture. So if I fix this, so 3 by 1000, 4 by 1000, what happens? So if numerator is increasing, I can easily say omega is increasing, mass of vapor is increasing. I can clearly say. That's why in air conditioning, all calculations are based on fixed part. Now what is the unit? We express this as kg of vapor per kg of dry air. We express it as mass of vapor is kg of vapor, mass of dry air is kg dry air. So omega is expressed in terms of kg vapor per kg of dry air. Are Babulu, are we clear? My dear students, is it clear? अब इसका equation देखेंगे sir. We'll try to develop an equation. Observe clearly. Let mv be the mass of vapor, mv be the mass of dry air. Now, one more thing, sirs. When you take a sample of air, I repeat, when you take a sample of air, my vapor is occupying the entire volume. Agreed? Please listen carefully. It's not that, अरे यार आप air को देख लेना. Our vapor is spread throughout, dry air is spread throughout. So this dry air is occupying complete volume. Vapor is occupying complete volume. It's not that vapor is occupying one corner, dry air is occupying other corner. No. So whatever vapor is there, it is spread throughout. Whatever dry air is there, it is spread throughout. So can I say volume occupied by vapor is equal to volume occupied by dry air is equal to volume of the mixture. This V is volume of the mixture. This V is volume of the mixture. Please tell me, is it clear? Let me repeat, sirs. So our vapor is occupying the entire volume. Dry air is occupying the entire volume. I repeat, sirs. Vapor is occupying entire volume. Dry air is occupying entire volume. So vapor is occupying complete volume. So volume of vapor is this volume of mixture. Dry air is occupying entire volume. So volume of dry air is volume of mixture. So this is one. And one more thing. Whenever you take sample of air, are you finding any difference in temperature? Whether you touch here or here, whether you touch here or here or here or here, everywhere the temperature is same. So can I say it is in equilibrium? So temperature of vapor is equal to temperature of dry air is equal to temperature of air. Let me explain, sirs. Are yaar, I'm just moving my palm. I'm just moving my hand. Everywhere I am finding the temperature same. So water vapor ho ya dry air ho, everywhere the temperature is same because it is in equilibrium. So temperature of dry air is equal to temperature of vapor is equal to temperature of the mixture. What do I mean by mixture? Because there is water vapor, there is dry air. It is known as mixture. Wonderful, sirs. Is this okay, sirs? Now, देखो यहां तक सभी को समझ में आया सर? I'm waiting. यहां तक सभी को समझ में आया? Thank you, sirs. बहुत स्मूथली चल रहा है सर. नो वेस्टेज ऑफ टाइम. वो मेरा मोटो है सर. वो मेरा मोटो है सर. नो वेस्टेज ऑफ टाइम. इज इट ओके? इज इट ओके? डॉक्टर उमा जी भी आ गए देखो. इज इट ओके? वंडरफुल स्टूडेंट्स ऑफ इंडिया. वंडरफुल स्टूडेंट्स. अब देखना सर. लेट पीवी बी द पार्शियल प्रेशर ऑफ वाटर वेपर. लेट पीए बी द पार्शियल प्रेशर ऑफ ड्राई एयर. सर ये समझ में नहीं आया सर. What is partial pressure of vapor? What is partial pressure of dry air? Please थोड़ा explain करो. Very good. एक काम करो sirs. You have a mixture of vapor and dry air. Hypothetically, you remove entire dry air. अरे यार, what is the total pressure here? The total pressure is partial pressure of vapor plus partial pressure of dry air. Do you know Dalton's law of partial pressure? If you want, I can derive. I have no problem. So, यहाँ पे the total pressure, it is atmospheric pressure. My air is under atmospheric conditions. Whether it is dry air or water vapor, it is atmospheric conditions. So, therefore, this total pressure is also known as atmospheric pressure. This total pressure is also known as atmospheric pressure. So, the total atmospheric pressure, it is a two-component system. It is the sum of partial pressure of vapor and partial pressure of dry air. Sir, थोड़ा partial pressure का meaning बताओ. Very good. Hypothetically, let us remove all dry air. पूरा dry air को हटा देना. Now it is occupied only by vapor. So if there is only water vapor in the same volume and at the same temperature, we are neither changing the volume. There is a container. In that container there is dry air. There is a container. In this container there is dry air and water vapor. So it is occupying a volume V and it is at temperature T. You remove all dry air. Now there is only water vapor. So in the same volume and at the same temperature, whatever the pressure the vapor alone is exerting, that is known as partial pressure of vapor. Similarly, when you remove complete water vapor, in the same volume and at the same temperature, whatever the dry air is exerting, it is known as the partial pressure of dry air. यहाँ तक clear है sirs? Is it okay sirs? So this is the total atmospheric pressure. Now, we have studied in thermodynamics mixture of ideal gases is also an ideal gas. Now suddenly one question comes. Sir, dry air. Yes, it is an ideal gas, no problem. But it has water vapor, na? How can I treat water vapor as an ideal gas? Please understand carefully. एक बात बताओ, sirs. How is water vapor in air existing? How can you see water vapor as water? No. It is in what state? Anyone? It is in what state? It is in gaseous state. So therefore, water vapor in air is existing in what state? Superheated state. Let me tell you very clearly, water vapor in air, can you see liquid droplets? No. It is in vapor state. It is completely in vapor state. So water vapor in air is existing in superheated state. Sir, what do we mean by superheated state? Wait, I'll explain everything. यहां तक सभी को क्लियर है सर? यहां तक सभी को क्लियर है सर? बोलो रे. Wonderful. Now, my dear students, the atmospheric pressure is about 101 kilopascal. And the dry air part is about 98 kilopascal. And what is the partial pressure of vapor? It's about, don't say that this is fixed. This can vary little, but I am giving you the generalized value. So with this is 3 kilopascal. What is the partial pressure of vapor? It is very low. Just to see what is the partial pressure of vapor, it is very low. Your teacher of thermodynamics has taught in thermodynamics, superheated vapor can be treated as an ideal gas when its pressure is low. What is the pressure of water vapor? The pressure of water vapor is so low that I can treat water vapor which is existing in the air as ideal gas. So अब इसको भी दर्जा मिल गया. It too got authority to be treated as this one vapor as ideal gas. Already dry air is ideal gas. Now as water vapor is existing at very low pressure, so at low pressures you can treat the gas as an ideal gas. So when I treat the gas as an ideal gas, so it is a mixture of ideal gases. Now I will treat the mixture of dry air and water vapor as a mixture of ideal gas. In interviews they may be asking, how can I treat water vapor as an ideal gas? So your answer should be like this, sir. Water vapor in air exists in superheated state, and moreover it is at low pressure. As it is at low pressure, I can treat a gas as an ideal gas. But the same question he will ask you. In Rankine cycle thermal power plants, can we treat superheated vapor as an ideal gas? There in Rankine cycle, the pressure will be very, very high, 180 bar, 200 bar. So at high pressures, you cannot treat the gas as ideal gas. I beautifully explained this in my thermodynamics. So can I treat this water vapor in this case as an ideal gas, atmospheric air? Yes, because its pressure is very low. All of you, are we clear? All of you, are we clear? बोलो सर्स, बोलो कितना अच्छा चल रहा है. वाह रे वाह, मजा आ रहा है. मजा आएगा रे, अब मजा आएगा रे. अरे. Now look at, there is a mixture, there is water vapor, there is dry air, and one more thing. आप बताइए सर्स, what is the temperature of vapor? It is same as the mixture. What is the temperature of vapor? It is same as the mixture. Yes or no? Because it is existing in equilibrium. So temperature of vapor, temperature of dry air is also temperature of our moist air. Now, my dear students, what is the pressure of vapor? It is PV. Hope you have understood what is PV, partial pressure. So if there is a combination of gases, if I remove other gases, if only one gas is present in the same volume and at the same temperature, whatever the pressure that single gas is exerting in the same volume and temperature, we call it as its partial pressure. The total pressure is equal to sum of the partial pressures. Ab dekho sirs. Now, let us take TS diagram. You may be laughing at me. Sir ji, ye kya kar rahe hai? It is dry air. How can I treat dry air as liquid vapor? Can dry air undergo condensation? No, na. So whenever I am showing in psychrometry this chart, my dear students, whenever I show this chart in this diagram in psychrometry, it is actually for water vapor which is present in air. It is not for dry air. Ye jo bhi diagram मैं दिखा रहा हूं, whatever the diagram I am showing in psychrometry, this diagram, phase change diagram, liquid, liquid plus vapor, saturated liquid, saturated vapor, superheated region. It is for water vapor which is present in air. It's not for dry air. समझ में आया sir? Have you followed? So this is for water vapor. Now देखो, how is our water vapor existing? It is existing in superheated state. It is existing in superheated state. What is the temperature, sirs? Temperature of vapor, it is same as the temperature of mixture. So let the temperature be TV or T. Let the temperature be TV or TV. 1 second please. 1 second. Now let the temperature of this be TV. Where is our water vapor? Our water vapor is in superheated gaseous state. Superheated gaseous state. Let us say this point. Can anyone tell what is this point representing? This point is representing the state or condition of water vapor which is present in air. That water vapor temperature is TV, which is same as the mixture temperature. And what is the pressure? The water vapor pressure is PV. So draw constant pressure lines. You know, on TS diagram, these are constant pressure lines. So please note down that our water vapor which is present in air, its partial pressure is PV and its temperature is T. So please note down that this is the state of air, this is the state of water vapor which is present in air. Have you followed? Please note down that it is not the state of dry air, it is the state of water vapor which is present in air. So that water vapor on cooling may undergo condensation, may get converted from vapor to liquid state, depending on conditions. यहाँ तक clear हुआ sirs? यहाँ तक clear हुआ? Wonderful sirs, wonderful. No problem at all. Now, look at carefully. Can I treat water vapor as ideal gas? Yes. Can I treat dry air as ideal gas? Yes. अब देखो, just now I told you dry air is an ideal gas. Water vapor can also be treated as an ideal gas because its pressure is very, very low. Apply ideal gas equation. PV is equal to MRT. In thermodynamics, I taught you very clearly. Whenever you are applying ideal gas equation, I taught very clearly. Kelvin scale and ideal gas temperature scales are same. So in ideal gas equation, temperature should be strictly in Kelvin. I taught very clearly. Now let me apply this ideal gas equation for dry air. Let me apply this ideal gas equation for water vapor. अब देखना dry air के लिए क्या होगा? PA VA is equal to MA RA TA. Similarly for water vapor, yes, I can apply PV VV is equal to MV RV TV. Absolutely fine. अभी तो बताया था whether it is water vapor or dry air, if you just move your hand, whether it is water vapor or dry air, it is in equilibrium. So therefore, temperature of dry air is equal to temperature of water vapor is equal to temperature of our air, moist air. Similarly, my water vapor is occupying complete volume, so volume of vapor is equal to my dry air is occupying complete volume. It's not कि water vapor एक कोने में है, dry air एक कोने में है. No, it is spread throughout. So volume of vapor is equal to volume of dry air is equal to volume of the mixture. So now I'll write here. देखो. PA, what is VA? What is VA? What is VA? It is V, volume of the mixture, is equal to MA RA TA. What is TA? It is T. Similarly, what is this? PV. What is VV? VV is volume of the mixture, is equal to MV RV, and TV is nothing but T. What do you want? I want omega. I want omega. What is omega? MV by MA. There is MV, there is MA. So let's divide this with this. So I will write this as PVV by PAV is equal to this by this MV RVT by MA RAT. So TT is gone, VV is gone. So MV by MA is equal to PV by PA. Let me write MV by MA is PV by PA. This RA will PV by PA. This RA will come this side by RV. Absolutely fine. अब आप देखेंगे सर. Now I'll go to the next slide. But what is MV by MA? My dear students, what is MV by MA? It is specific humidity. What is specific humidity? It is the ratio of mass of vapor to the mass of dry air. This is our omega. Omega is equal to PV by PA into RA by RV. I will take this equation and go to the next slide. Till now, is it clear, dear students? Till now, is it clear? Bolo. I'm waiting for your answers. You are not saying anything. Till now, is it clear? Yes, yes, yes. Wonderful, wonderful, wonderful. Fadafat, fadafat. Great, great. Crystal clear, Deepak. Very good. Amit. Okay, Sachin Babu. ललित बाबू भी आ गए, निकिता, अभिषेक, राघवेंद्र, हमारे राघवेंद्र आ गए, अभिषेक, उमा जी. अच्छा, अच्छा. Right. Now let's take this equation and go to the next slide. So therefore, omega is equal to, बोलो एक बार क्या है, PV by PA into RA by RB. Very good, sirs. You might have studied in thermodynamics. I taught you very clearly. The characteristic gas constant is equal to universal gas constant by molecular mass. Now, what does RA mean? It is R bar by molecular mass of air. Air. What is the molecular weight of air? 29, 28.97, or roughly I take it as 29. So dry air का होता है 29. So R bar by dry air has a molecular mass of 29. So 29. Now, what is the molecular weight of vapor? RV is vapor. So R is R bar. This is from basic thermodynamics. R bar by molecular weight. What is the molecular weight? It is vapor. Vapor is nothing but H2O. It is 1, but there are 2 atoms of hydrogen plus oxygen. It is 16. So therefore it is 18. So therefore R bar by 18. So you can calculate this. There is no problem. And what is the value of R bar? 8.314 kilojoule per kilomole Kelvin. You know it very well. So let us put it here. So therefore PV by PA into RA. What is RA, sirs? R bar by 29. And what is RV? What is RV? Anyone? What is RV? R bar by 18. Great. So omega is equal to PV by PA into R bar. R bar is gone. 18 by 29. What is 18 by 29? If you calculate, you get it as 0.622. If you calculate this value, 0.622, PV by PA. What is PV? Partial pressure of vapor. What is PA? Partial pressure of dry air. So look at carefully. So omega is equal to, एक second देखो, 0.622 PV by PA. Great, sirs. Hold on. Just now I told you that total atmospheric pressure is given by partial pressure of dry air plus partial pressure of vapor. So what is partial pressure of dry air? It is the total pressure minus partial pressure of vapor. So therefore omega is equal to 0.622 PV by, what is PA? What is PA? P total minus PV. Now let us make some beautiful conclusions. So this derivation is very, very important. With what assumption we have derived this equation? With the assumption that the moist air is a mixture of ideal gases. The water vapor can be treated as ideal gas as its pressure is low, and dry air is already an ideal gas. So with that assumption I have derived. Now let us make some beautiful conclusions. Till now, is it clear? Till now, is it clear? Bolo, 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 bolo. So let's not waste time. Come on. Let us learn to the perfection. Now, dekho, sirs. Please listen. PT is the total atmospheric pressure. PT is total atmospheric pressure. Can I say the atmospheric pressure is more or less constant? Can I say the atmospheric pressure is more or less constant? ये तो almost constant है, around 100 kilopascal or 101 kilopascal. It is more or less constant. What do you mean by more or less? Almost constant. So when this is constant, my omega depends on what, sirs? My omega depends on what? If this is constant, my omega is a function of partial pressure of vapor. So omega is a function of partial pressure of vapor. And you may be wondering, why are you taking this condition? When I start explaining you the development of psychrometric chart, you'll understand the logic behind this. This is very, very important, sirs. The specific humidity is a function of partial pressure of vapor. Great. What is it actually signifying? It is actually showing in my sample of air, how much is water vapor. It actually shows what is the content of water vapor. How much, see, what is the definition of omega? It is mv, I repeat, it is mv by ma. So what is the definition of omega? It is the mass of vapor to the mass of dry air. It actually is, it is representing how much water vapor is present in actual air. So this is about specific humidity, and its equation is 0.622 PV by P total minus PV. Absolutely clear. And if you want to write its unit, mv is kg of vapor and ma is kg of dry air. So this specific humidity is also known as humidity ratio. Now, sometimes what happens, some people use the word absolute humidity. Some textbooks, if you see, they also put this under the category of specific humidity or humidity ratio. But actually, some other books give it as, it is the mass of vapor in a certain volume of dry air. देखो, there is mass of vapor in this volume. एक second, फिर से बता रहा हूँ. There is mass of vapor. This is the sample of moist air. So it is occupying, let us say, volume V. Let us say I have taken some air. The volume of air which I took is V. So this absolute humidity actually shows in a given volume of air how much is water vapor. So now you may be wondering, sir, you also said absolute humidity is also equal to specific humidity. Now you are saying absolute humidity is equal to mv by volume. You should just check the unit. अगर ये kg of vapor per kg dry air देता है, it is actually per unit volume how much is the mass of vapor we are expressing. Otherwise, it is the same. Please understand, it is just checking at the unit you have to tell, checking at the unit. But please understand, but mostly books give, most of the literature says absolute humidity as in a given volume of air, how much is mass of vapor, that is absolute humidity. But if sometimes loosely they also use it as specific humidity, but checking its unit you have to tell. Checking its unit you have to tell. Please tell me, is it clear? Let us say in examination he'll ask, सुनो carefully. Now you may be saying, sir, आपने तो बोला कि absolute humidity is same as specific humidity, so it is kg vapor per kg dry air. Let us assume that tomorrow in examination, he'll give one question, and what is the absolute humidity? A, some value, so many kg vapor per meter cube of dry air. Sir, आपने तो बोला kg vapor per kg dry air, but options में kg vapor per meter cube आ रहा है. It means checking at the units, you have to proceed, which I'll be doing some questions on this. Up to this, are we clear, sirs? Up to this, is it clear? Is it clear, my dear students? तो ओमेगा का कोई प्रॉब्लम नहीं है. ओमेगा का कोई प्रॉब्लम नहीं है. Shall we proceed? Wonderful, wonderful, my dear students. Absolutely fine. No problem at all. No problem at all. Let us proceed, sirs. So the first term that we saw is specific humidity or humidity ratio. Okay, and also we saw absolute humidity. Now, second, relative humidity. After this, we'll see why these two are used. Why these are used after this. Now, understand carefully. Let us take a sample. Some textbooks designate with RH and some textbook designate with phi. Relative humidity or it is RH or phi. Let us take certain sample of air. Whenever I say certain sample of air, it is which air, sirs? It is moist air. It is moist air. In moist air, what do we have? There is water vapor and there is dry air. There is water vapor and there is dry air. Now, let the partial pressure of vapor be PV and let the partial pressure of dry air be PA. Let the volume of this mixture be V, this volume of the mixture, and complete mixture is at a temperature T. This information is given to us. This information is given to us. Great. Now, this specific relative humidity is defined as the actual mass of vapor present in air to the mass of vapor under saturation condition in the same volume and at the same temperature. मैं फिर से explain करूंगा, sirs. Do not worry. After explaining this mathematically, then I will give you the physical meaning of both. Physical meaning of both. Don't worry, sirs. Now देखो, what is relative humidity? It is the ratio of mass of vapor to the mass of vapor under, it is the ratio of actual mass of vapor to the mass of vapor under saturation conditions in the same volume and at the same temperature. I have told you very clearly, at every particular temperature, my air has capacity to absorb certain moisture. Let me repeat this. At every particular temperature, it can absorb certain amount of moisture. Something like this. You have certain capacity to eat. Other student has a capacity to eat some other quantity. So it varies from temperature to temperature. What do I mean by this? Such an air, matlab, look at carefully. Assume that it at this particular temperature, it can hold some more amount of moisture. When it can hold some more amount of moisture, means this air is unsaturated. It's not saturated. If it is saturated, it cannot hold further. So it means it can take some more amount of moisture. It can take some more amount of moisture. So such an air is known as unsaturated air. What does unsaturated air mean? It means that it has some more capacity to absorb moisture. So it is having less amount of moisture compared to saturation conditions. Such an air is known as unsaturated air. Such an air is known as unsaturated air. Are Baba, are we clear? Now, what is relative humidity, sirs? Ab dekhenge. Let's see what is relative humidity. Understand carefully. Wait. So this is actual air. This is actual air. Now, what did I say, sirs? एक second, please. This is actual air. Relative humidity is defined as actual mass of vapor to the mass of vapor under saturation conditions. अब एक काम करो, sirs. Now you do one thing. What is that? What is that? Listen, sirs. What did I say? In the same volume and at the same temperature. Is it saturated? It is unsaturated. What does it mean? It has capacity to absorb some more amount of moisture. So add. And you know very well, when you are adding moisture, the moisture content is increasing. So its partial pressure will also increase. It's something like this. You have got tomatoes and potatoes in a mixture. If you are adding potatoes, its partial content will increase, na? So that's what I am saying. So when I am adding moisture, its partial pressure will increase. How long are you adding? How long can it take until it reaches saturation? But what is the condition? You have to add in the same. ऐसा करो आप, एक काम करो. There is a container. Let its volume be V. मान लो इसका volume V है and its temperature be T. Let its original mass of vapor be mv. It is unsaturated. Imagine. So definitely it can absorb some more amount of moisture. So in the same volume and at the same temperature, now you add moisture. How long it can take until it reaches saturation? After that it will vomit. It will come out. So now you add moisture until my mass of vapor is becoming saturated. What is MVS? It is the mass of vapor under saturation conditions in the same volume and at the same temperature. Now you tell me, sirs, as I am adding moisture, water vapor, what will happen to the partial pressure of vapor? It will also increase. It will also increase. So this will become, my PV will become PVS. My PV will become PVS. Is it clear or not, sirs? अरे यार आप भी मजाक कर रहे हैं, sirs. मेरे पास actually sample of air है. In that sample there is mv kg of vapor and its partial pressure is mv. So in the same volume and at the same temperature, let us add moisture. How long I am adding? Until it is reaching saturation. My mv is becoming mvs. So corresponding to mvs, pv will become pvs. Great. So what is relative humidity? What is relative humidity? It is the ratio of actual mass of vapor to the mass of vapor under saturation conditions. First, let us see mathematically, then we will see physically. First, let us see mathematically, then we'll see physically. Great, sirs. Thank you, Deepak. Thank you. अच्छा, मुझे क्या अच्छा लग रहा है पता है? Even though it is a YouTube class, everyone is disciplined. I really salute you people. Let us prove everyone wrong. Ki on YouTube also we can conduct beautiful, sincere, dedicated classes similar to offline environment. Let's prove that. You have already proved with our with the help of our channel. So you have shown so much respect, sir. Thank you for that. अब देखते हैं. First we'll see mathematically, then we'll see physically. थोड़ा इसको हम represent करेंगे, sir. We'll try to represent. Cool raho. I know my students are always great. I know my students are always sincere. I know always my students are dedicated. I know all my students are sincere. They are pure at heart. I know it. है ना? वाह. अब मनीष कुमार पूछ रहा है सैचुरेशन का मतलब, तू एक पैकेट बिरयानी खा रहा है, 2 पैकेट बिरयानी खा रहा है, 3 पैकेट बिरयानी खा रहा है, 4 पैकेट बिरयानी खा रहा है, 5वां खाने के बाद वॉमिट कर रहा है, दैट इज सैचुरेशन. सो आपका सैचुरेशन 4 बिरयानी, बस खत्म, इससे ज्यादा नहीं बोलूंगा. समझ गए ना? सेम एयर है, एयर में मॉइस्चर एब्जॉर्ब कर रहा है, तो कहां तक एब्जॉर्ब करेगा? टिल इट रीचेस सैचुरेशन. एक स्टेज, अरे यार आपको सैचुरेशन नहीं है तो मैं क्या करूं सर? एक ग्लास पानी ले लेना. सुनो केयरफुली, एक ग्लास पानी ले लेना. You add sugar 1 spoon, 2 spoon, 3 spoon, afterwards it will come out. So after second spoon when it is coming out, its saturation is 2 spoons. तो एक काम करो सर साहब, let us heat water. सेम पानी को गर्म करना, तो क्या होगा सर? You can add some more amount of sugar. So when I increase the temperature, the absorbing capacity is also increasing. Understand carefully. आप एक काम करो सर, you take normal water and add sugar, and you take heated water and you add sugar. The absorbing capacity, the saturation is not same. Same is the case. So air has got absorbing capacity different at different temperatures. So as the temperature is increasing, the absorbing capacity increases. ये सब हम discuss करेंगे. Now, whenever I draw this diagram in psychrometry, it is for what? Is it for dry air or is it for water vapor? बोलो सर, एक बार comments में बोलो. Is it for dry air or is it for water vapor? बोलो. Is it for dry air or water vapor? Whenever I saw water vapor. Wonderful. नहीं नीतीश, नहीं. Wonderful, water vapor. अब देखो सर, please listen. There is mass of vapor, its partial pressure is PV. There is mass of vapor, its partial pressure is PV. There is mass of dry air, its partial pressure is PA. Let us say the temperature of vapor is TV, which is also equal to T. The temperature of dry air is TA, which is also equal to T. What does T mean? It is the temperature of air. Now, look at carefully. This is the temperature of vapor. This is the temperature of vapor, which is also equal to temperature of mixture. And this is the partial pressure of vapor. Now, dekho sirs, this is representing the actual state of water vapor. This is actually representing the actual state of water vapor in our moist air. Now, what are you doing? You are adding moisture. But at what condition you are adding? At the same temperature. When I say same temperature, how do I show same temperature, dear students? How do I show same temperature? It is by a horizontal line. Same temperature line. Now, you know when you are adding moisture, what is happening to the partial pressure of vapor? It is increasing. When I am adding moisture, the partial pressure is increasing. इसका मतलब है along the same horizontal line, it is moving towards saturation. Along the same horizon, this is unsaturated air and this is saturated. So along the same horizontal line, it is moving towards saturation. So let us add some moisture. after some time. Let us add some moisture. After some time, it is here. Again you add moisture, it is here. Again you add moisture, yes. Can I say this is the mass of vapor under saturation conditions? Dekho, I have added. So therefore, at the same temperature in the same volume, my MV is becoming MVS, my PV is becoming PVS. Ab dekhna sirs. Now, initially it was at this condition. When I was adding moisture, it reached saturation state. So therefore, but I should move along horizontal. Can you tell me why along horizontal line? Because at the same temperature you are adding, same temperature means temperature is taken on y-axis. Therefore, it is horizontal. So you are adding moisture, adding moisture, adding moisture. This is saturation. Now, please understand, my dear students. Idhar dekhna. एक सेकंड प्लीज आई विल चेंज दूसरा कलर ले लेंगे व्हाट इज दिस प्रेशर एनीवन ये प्रेशर क्या है आई विल राइट दिस एज पीवीएस लेट मी राइट वेरी क्लियरली आई विल राइट दिस एज पीवीएस ऑब्वियसली ये ऊपर है दिस इज पीवीएस ये नीचे है इट इज पीवी डेफिनेटली व्हेन मॉइस्चर इज एडेड द प्रेशर इज इंक्रीजिंग पार्शियल प्रेशर इज इंक्रीजिंग इससे ये प्रेशर ज्यादा है द पार्शियल प्रेशर इज इंक्रीजिंग नाउ वी हैव रीच्ड दिस. So please understand, are we clear? This is actual mass of vapor and this is mass of vapor under saturation conditions. So this is the actual mass of vapor which is corresponding to PV. This is mass of vapor under saturation which is corresponding to PVS. Are Baba, are we clear? My dear students, are we clear? Dear students, are we clear? Are we clear? Chalo. Now let's understand the point very, very clearly. एक सेकंड देखना इधर. Let's understand very clearly. This is my actual, so I will write this as PV. I will write this as actual temperature T. Actual temperature T. Wait, sirs. एक second, please. I'll erase this. Okay. Now, this is actual temperature of vapor, which is also T. Now, you are adding moisture. So this is my saturated vapor conditions, which is PVS. Very good. Look at it is also vapor. Can I apply ideal gas equation for vapor? Yes, its pressure is low. Partial pressure of vapor is very low. Let me apply. Dekho, this is the actual condition MV, corresponding PV, and temperature is T and volume is V. And this is saturation condition MVS, and corresponding pressure is PVS and the volume is temperature is T, volume is V. Let's apply. I am applying ideal gas equation for vapor. How do I apply? P of vapor, volume of vapor is equal to mass of vapor, R of vapor, and T of vapor, which is T only. Let me repeat, sirs. I am applying ideal gas equation for this vapor. What is the pressure? PV. PV is partial pressure of vapor. PV is equal to MRT. PV. My V of vapor is same as volume of the mixture is equal to mass of vapor is MV, R of vapor is RV, and T is the temperature of this mixture. Let us apply ideal gas equation here under saturation condition. किसके लिए apply कर रहे हैं? Vapor. So now my pressure is PVS. PV. P is PVS. V is V is equal to M. M is MVS. RV. Don't write RVS. Why are you just write RV is enough? Why, sir? Whether it is, what is RV, sirs? R is R bar by molecular weight. Whether it is vapor or saturated vapor, what is the molecular weight, sirs? Whether it is vapor or saturated vapor, it is H2O. H2O का मतलब क्या है? 18. Whether it is vapor or saturated vapor, the molecular weight is 18. So therefore, I will not write RVS. Even if I write RVS, it is RV only. The gas constant of vapor under saturation conditions or gas constant of vapor under normal condition is same because it is R bar by molecular weight. Whether it is saturated vapor or unsaturated vapor, it is vapor, it is H2O. H2O means molecular weight is 18. So वो तो same है and at the same temperature. PV is equal to MRT हो गया sirs. What is your equation for relative humidity? It is what? Mass of vapor to the mass of vapor under saturation conditions. So therefore, now just divide these two. ये दोनों को divide कर रहा है sir. Let's divide these two. Let me divide these two. एक second. Let me divide these two. Then I will give you the physical meaning of both. देखो, PVV is equal to MV RVT by PVSV. क्या होगा? PVSV is MVS RVST. Exactly. तो दिस बाय दिस, अब देखो V इज गॉन, RVS is same I said because molecular mass is same, T is gone. So what is MV by MVS? तो MV by MVS is equal to PV by PVS. But what is MV by MVS? Actual mass of vapor to the mass of vapor under saturation conditions is relative humidity, and therefore phi is equal to PV by PVS. How do I define relative humidity? It is the actual partial pressure of vapor to the partial pressure of vapor under saturation conditions in the same volume and at the same temperature. Up to this, is it clear? If it is clear, then I'll go for physical explanation of this. बोलो sirs, अगर यहां पे clear है तो I'll go for physical explanation. बोलो 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 sirs, is it clear? I'm waiting. थोड़ा fast बोलो. Clear? वंडरफुल, एकदम मस्त. थैंक यू. वाह, हमारे हिमेश शर्मा है तो जिंदाबाद है, हमारे बुजुर्ग हिमेश शर्मा है तो जिंदाबाद, कोई दिक्कत नहीं. हिमेश बाबू जय. लास्ट के 5 मिनट में आपके डाउट्स ले लूंगा. लेट अस सी द फिजिकल एक्सप्लेनेशन ऑफ दिस. बहुत केयरफुली सुनेंगे सर. नाउ स्टूडेंट्स कैन आस्क सम क्वेश्चंस. सर ह्यूमिडिटी इज देयर, बट ये दो टर्म्स क्यों? दोनों भी ह्यूमिडिटी शो कर रहे हैं. वन इज स्पेसिफिक ह्यूमिडिटी, वन इज रिलेटिव ह्यूमिडिटी. व्हाई डू वी नीड टू? नाउ लेट्स अंडरस्टैंड वेरी क्लियरली सर. लेट्स अंडरस्टैंड वेरी क्लियरली. ओमेगा इज इक्वल टू mv by ma. Omega is mv by ma and phi is equal to mv by mvs. Great sirs, great. Let's see the difference between these two. My omega is showing the actual mass of vapor present in moisture. It shows actually how much vapor is present in air. It actually shows how much vapor is present in air. If this is showing the actual mass of vapor present in air, then what is this showing, sirs? In interviews, if they ask you what is the difference between omega and phi, omega is showing the actual mass of vapor in certain moisture. Then phi is showing moisture absorbing capacity. What do I mean by moisture absorbing capacity? अब बहुत केयरफुली सुनना सर. अब इस पॉइंट को बहुत केयरफुली सुनना. This relative humidity, in interviews if they ask you what is the significance or what it is signifying, you should tell that it is actually showing the moisture absorbing capacity. It is actually showing the moisture absorbing capacity. How? मैं बताता हूं. सुनो सर, look at carefully. बहुत केयरफुली सुनना सर. There is a state of air at 1, there is a state of air at 2, and there is a state of air at 3. All are at the same temperature. मान लो मेरे पास air है, all the 3 are at the same temperature. देखो, you draw a horizontal line, you can understand. You draw a horizontal line, you understand that all are at the same temperature. So all are at the same temperature. Great. देखो, this is my PV. So I will write this as PV1. It is the partial pressure of vapor at state 1. So now let's take the different color. ये वाला लेंगे. Let's take a different color. एक second please.
कुछ बोलता है रे ये, इसको क्या हो गया रे, क्या करे रे.
Yes. Now देखो, is it okay? ओके सर, ओके सर. बोलो एक बार. ओके सर, ओके सर. हमारे रेगुलर क्लास की तरह. नाउ देखो. ओके सर, ओके सर. दिस इज आवर PV2. ये वाला अच्छा लगा. दिस इज आवर PV3. एंड कैन यू टेल मी व्हाट इज दिस रे? बोलो रे बाबा रे. विच कलर इज टू बी टेकन? कलर कॉम्बिनेशन बहुत सही नहीं दिख रहा है यहां पे. आई विल टेक यस. यस, देखो देखो, आई विल एक्सप्लेन वेरी क्लियरली. अब आप देखना सर, आई विल एक्सप्लेन वेरी क्लियरली. इधर देखो, 4 दिन से भूखे हैं आप, तो कितना खा लेंगे सर सैचुरेशन होने तक? यहां से यहां इतना खा लेंगे. You are very far from saturation. Your saturation is here, you are here. So this state 1 is showing very far from saturation. बहुत भूखे है, खाली पेट है, खाली पेट है, मतलब when ये भरपूर पेट है, देखो ये full stomach, it is खाली खाली plate. When you are moving away from this, it is खाली खाली. कितना खा लेंगे? So this one will eat. ये तनुज है, देखो खाली खाली है, 4 दिन से नहीं खाया. He has not taken food for 4 days. तो क्या कितना खाएगा ये? पूरा यहां से लेकर यहां तक सैचुरेशन होने तक. So what is his absorbing capacity? High. It means when the point is very far from saturation state, इसमें क्या होगा सर? When it is very far from saturation state, it has more absorbing capacity. If that is very close to saturation state, means already saturation के करीब है. When it is already, for example, I'll tell you very clearly. Can you tell me what is phi 1? It is PV1 by PVS1. Don't write PVS1 because all are at the same temperature. So for 1, this is saturation. For 2, this is saturation. For 3, this is saturation. Can I say for 1, 2 and 3, all the saturation is same? What is the reason for that? Because all are at the same temperature. So for 1, this is saturation. For 2, this is saturation. For 3, this is saturation. So I am dropping this term PVS. So simply I write PVS. Similarly, dear students, so what is phi 2, sirs? What is phi 2? It is PV2 by PVS. अब आप बताइए सर, what is the relative, what is the partial pressure of this? Definitely PV2 ऊपर है, देखो this is PV2, this is PV2, this is PV1, this is PV1, this pressure. तो what is PV1? कम है, देखो इससे नीचे है, this is less. So can I say, let us say this is 0.25, मान लो it is 25%, it is 25%. Now what about PV2? Let us say it is PV2. Definitely PV2 is more than PV1. When PV2 is more than PV1, this value will be more. Let us say it is 0.5, which is 50%, let us say. Now you know, my dear students, if the relative humidity is less, it will be far from saturation, its absorbing capacity will be more. Let me repeat sir, अगर एक state of air का relative humidity कम है, if the relative humidity is less, मतलब वो बहुत भूखा है. If the relative humidity is less means पेट खाली है, so it is खाली खाली, so it will absorb more. So when the relative humidity is less, it will absorb more. इसका मतलब है, if the relative humidity is 0.25 and if the relative humidity is 0.7, what does it mean? It means if the relative humidity is less, it has less moisture content, so it will absorb more, it will absorb more, it will absorb more. If the relative humidity is more, it is close to saturation, it will absorb less. And if air is already saturated, मान लो वो already saturated है, मेरा point 1 से 2, 2 से 3, already मेरा 4th point इससे coincide हो रहा है. If the point is already saturated, what will look at? अगर वो already saturated है, तो मेरा PV क्या होगा सर? If it is already saturated, because this is not saturated, this is not saturated, this is not saturated, but if the point is already saturated, my PV will be PVS. So PV by PVS, my PV is already, if it is already saturated, my PV, if already the point is, देखो, originally my point was here. If there is a air whose point is already here, my saturation and actual are same. So actual saturation जब same है, तो ये कितना होगा? 1. 1 का मतलब क्या है? 100%. If it is already saturated, how much is the absorbing capacity? 0. So for saturated air, the absorbing capacity is 0 because it is already full. So in interviews, if they ask you what is the significance of relative humidity, your answer should be, it signifies the absorbing capacity, moisture absorbing capacity. If the relative humidity is less, its absorbing capacity will be more. If the relative humidity is more, its absorbing capacity will be less. If the relative humidity is 100%, it is already saturated, its absorbing capacity will be low. 0. Is it clear? All of you, is it clear? Bolo, bolo, bolo. So in interviews, if they ask you, sirs, what is the difference between omega and phi, your answer should be like this. Is it okay? आगे बढ़े sirs? Shall I proceed? Shall we proceed? एकदम सर, एकदम मस्त चल रहा है. Thank you, thank you, thank you, thank you, thank you, thank you. So अभी तक हमने 2 टर्म्स देखे सर्स. Now let us see the third term. बोलो, सब सही चल रहा है सर? Do you want me to continue like this? गोविंद मुरारी रेन का कॉन्सेप्ट कल बताऊंगा सर, सब एक ही दिन तो कैसा। नाउ कल क्या करेंगे हम, देखो रे, कल क्या करेंगे रे, हम एक वेट बल्ब थर्मामीटर लेंगे। सो दिस इज साइक्रोमीटर। साइक्रोमीटर लेकर हम ड्राई बल्ब मेजर करेंगे, वेट बल्ब मेजर करेंगे, ड्यू पॉइंट मेजर करेंगे। ऑल दिस लेट अस डू इट इन अ वेरी नीट मैनर, सो यू डोंट हैव टू वरी। नाउ बिफोर वी क्लोज एक छोटा सा क्वेश्चन कर लेंगे सर। प्लीज कंटिन्यू। शैल आई कंटिन्यू? मतलब ऐसे ही, आज तो नहीं करेंगे, आज पहला क्लास है, तो should I continue? If you want, I'll tell. आप बोलो रे। ओके सर, वंडरफुल। अरे हिमेश शर्मा तो अंत तक है। ओके, वाह। कोल्ड बॉटल में, हाँ सर, कल जब मैं ड्यू पॉइंट कॉन्सेप्ट बताऊंगा ना, टुमारो व्हेन आई टीच यू द कॉन्सेप्ट ऑफ ड्यू पॉइंट टेम्परेचर, आई विल टीच यू कि हाउ द कंडेंसेशन इज टेकिंग प्लेस. There is no guarantee that the condensation is taking place. It may condense, it may not condense. It all depends on the surface temperature of the bottle. So you might have seen, छोटा सा एक फील देके छोड़ दूंगा सर. Let us go for a morning walk. Let us go for a morning walk in summer and in winter. When you go for a morning walk in summer, you don't find your pant becoming wet. No. So you're देखो. See, when you are walking in winter, so you find dew on grass and thereby you find some wet, it's all wet surface. But in summer, you don't find that, even though I'm walking at 5:30 in summer, same 5:30 in winter. But why all this is happening? So sometimes when I take out bottle from the refrigerator, you don't find any dew or condensation occurring on the surface. But sometimes when I take out the bottle, you find condensation. For all these, I have to explain the concept of dew point temperature. Let us study in a practical manner. After studying in a practical manner, let us try to attempt questions. Is it clear? Bolo. चलो, अभी कुछ पूछना है सर आपको? रियली मजा आ गया सर, तो थैंक यू. तो ऐसे ही पढ़ेंगे हम. सो विल स्टडी लाइक दिस ओनली, विल स्टडी विदाउट वेस्टिंग टाइम. अब जाके आप वॉट एवर, सो एनी वे आई विल बी प्रोवाइडिंग नोट्स ऑल्सो, डोंट वरी. लेकिन अब जाके डोंट वेस्ट टाइम, इधर उधर के बातें मत करना, सिंसियरली पढ़ते जाना. इज इट ओके? थैंक यू माय डियर स्टूडेंट्स. अच्छा, उसका कोई नोटेशन नहीं देता सर, वी डोंट फाइंड एनी नोटेशन. ओके, वन सेशन ऑन थर्मोडायनेमिक रिलेशंस. अच्छा, आप एक बात बताओ, यूट्यूब में व्हेन आई एम कंडक्टिंग क्लासेस ऑन मैकेनिकल का फंडा, लाइक देखो 20-25 मिनट्स का कॉन्सेप्ट, किस कॉन्सेप्ट पे आपको चाहिए एक बार बता देना, सो दैट आई विल टेक केयर. थर्मोडायनेमिक रिलेशंस. ओके, अभी बोलो, सो दैट आई विल टेक इंटरव्यू के लिए, आपको फायदा होगा. मैं दे दूंगा ना रे हिमेश, नोट्स कैसे मिलेंगे? आई विल गिव ना. Meshing of gears. Okay. TD relations. Thermo. See, I'll not teach all complete pura sara. Why second law is qualitative? Acha. Already I have told you, na? In thermodynamics, I taught gas property, TD relations. Acha. Some people are manufacturing, please. Oh God, ये क्या हो रहा है रे? जो पढ़ा है वो छोड़ के. Okay. On this channel, I have made some videos you can enjoy. Okay, yes, I'll be taking care of Govind Murari's request. So I'll be taking care of Govind Murari's request. Please note down that. Soon it will be Govind Murari's request. चलो, आज के लिए बस इतना. Thank you. Goodbye. Good night. चलो, I'm closing the session, sirs. Love you all. तो कल, tomorrow again we are meeting at 8:30. टुमारो वी आर मीटिंग अगेन एट 8:30. शायद परसों ये वीडियो डिलीट हो जाएगा. टुमारो वी आर मीटिंग एट 7:30. आई एम सॉरी, टुमारो वी आर मीटिंग एट 7:30. देखो एक सेकंड,
कहाँ गया रे, कहाँ गया रे.
टुमारो what is the date? 12th October. Again we are meeting at 7:30 p.m. Okay, good night. चलो, bye bye, thank you. चलो.